This is Mr. Swinger's podcast. Section 7, apply determinants and Kramer's rule. Alright, today we're going to talk about determinants, which we actually already talked about the other day. A determinant is basically a number associated with any square matrix. Square matrix meaning 2 by 2, 3 by 3, 4 by 4. So today I'm going to show you a little bit about how to find the determinant. So here's how we denote determinant. If I say DET, that means determinant of this matrix right here. I could also put it another way. This is the same as me just putting this one line A, B, C, D inside and then putting another line. It looks like absolute value, but since it's a matrix, it's not. That does not mean the absolute value. This means these two lines that look like absolute value means determinant of this matrix inside, A, B, C, D. Now I taught you guys how to do these 2 by 2s. What you want to do is take this diagonal, which is AD, and subtract the other diagonal, BC. And this is your determinant. You will get a number. Alright, so if I give you this problem, number 1, if I write this 5, 4, 3, and 1, and I write this, I don't even have to write any directions. Knowing these two straight lines looking like absolute value but not, that means find the determinant of whatever's inside, this matrix inside. So what you want to do is, just what we said, take this diagonal, which is A times D, which is 1, minus the other diagonal, 3 times 4. And this will equal 5 minus 12, 12, which equals -7. Okay? Alright. Now example 2, you're going to do a 3 by 3 matrix. So let's clear the page. Number 2, 3 by 3. 2 by 2 is fairly simple, right? But as soon as you get to a 3 by 3, that's where it gets a little bit more complicated. So I'll write this 3 by 3 matrix down on your paper. 2, -1, -3. And what you have to do is you have to be neat in doing this, or you will circle the wrong diagonals. Not a good idea. And -2. So there's your matrix. Step 1 in finding the determinant. So I guess I should write something here. Determinant of this matrix, since I didn't use the looking like absolute value sign here. I have to write determinant of this is step 1. What we're going to do is rewrite the first two columns. So right beside this, I'm going to rewrite the first column, 2, 4, 3. I'm going to rewrite the second column, -1, 1, -4. Next step, I'm going to circle my diagonals. Now I'm going to draw a line because it'll be easier for me, but you may want to circle. Okay? There's a diagonal, there's a diagonal, and there's a diagonal. What I'm going to do now is I'm going to write the product of each diagonal. So I'm going to multiply these three numbers, 3, 1, and -3, and get -9. 4, 0, 2, I'm going to get 0. -2, 4, -1 becomes 8. Alright, those are my upward diagonals. Now I'm going to do my downward diagonals. Change the color here. Now every diagonal has to have 3 elements in it. There's 1, 2, 3, 1, 2, 3, and 1, 2, 3. My downward diagonal, let's find the product of each of those. 2, 1, -2 becomes -4. There's a 0 in here, so multiply, I still get 0. Here, negative 3, 4, negative 4 becomes 12 times 4, 48. Alright, almost finished. How do we finish the problem? So these are called our downward diagonals. Now the book doesn't exactly do it like this. They do, but they don't explain it, so I'm just explaining it in more detail for you. Here is how you finish the problem. You find your upward diagonals, you find your downward diagonals, and what you want to do is you might want to circle these three, circle these three. The last step, we take our downward, I should say this, the sum of the downward diagonals minus the sum of the upward diagonals. Okay, so let's do the sum of the downward. Downward right here, we're going to add all these together, which make 44, minus the sum of the upward, negative 9 plus 0 plus 8 becomes negative 1. Lastly, add these up. 45 is our determinant. Sorry, it's a little sloppy. Okay, example number 1 is finished. That is how to find the determinant of a 2 by 2 matrix and a 3 by 3 matrix. This method, by the way, is called the diagonal method. Determinants can also be used for finding an area of a triangle if we're talking about a grid, or it can be used to actually solve systems of equations, which you know actually several ways to solve systems of equations. So it could be one more way that could actually be easier if you do it this way. So let's look at an example of a triangle. Example number 2. We're going to use determinants to find the area of the triangular region right here. So read this with me. Sea lines off the coast of California lies a triangular region in the Pacific Ocean where huge populations of sea lions and seals live. The triangle is formed by imaginary lines connecting Bodega Bay, Farallon Islands, Año Nuevo Island as shown. In the map, the coordinates are measured in miles. Use a determinant to estimate the area of the region. So determinants, like I said, are used to also estimate areas of triangles. So how do we do that? Well, you notice the coordinates up here. We couldn't do it unless we had these coordinates. Let's get these coordinates and we're going to put them in a matrix. You see 6 coordinates, well, 6 values for x and y that we're going to put in the matrix. So we're going to put these coordinates in here. So what's going to happen is we're going to put our x's here and our y's here. So negative 1 comma 41 was one coordinate. I know 0 comma 0 is another coordinate, and 38 negative 43 is another coordinate. It doesn't matter which order you put A, B, or C, the coordinates. But we can't find the determinant of this because it's a 3 by 2. We need a square matrix. So what we're going to do is we're going to fill in the last column with 1s. So anytime that you find area of a triangle, you're going to fill in the last part with 1s. So when you find area, normally you, off to the side, area equals 1/2 the base times the height. Well, kind of similar to that. Basically, the area, when using determinants, is 1/2 times the determinant of this matrix. Okay, so really, technically, I should do this to indicate determinant. I should be, okay, it doesn't work here, but I should make just straight up and down. Remember, I shouldn't have the matrix here. Should just be doing that. It's like absolute value. So 1/2 of the determinant of this matrix right here is equal to your area of a triangle. And that happens every time. But there's one little thing you have to do, plus or minus out front. Because area cannot be negative, so we put that out front just so in the end our answer will be positive. Alright, how do we do this? Well, let's use the formula we had before. We're going to rewrite the first two columns, -1, 0, 38, 41, 0, -43. Okay, now let's do our diagonals. There's 1, upward. Multiply those, it's 0. Here's the second, upward. Multiply those, 43. And the third, upward. That's nice. 0 again. Alright. Next one, let's do the downward. -1, 0, 1. There's another 0. 41, 1, 38, 1,558. And lastly, this one is 0. So what we do is we take our downward, which are here, add them all up, 1,558. Subtract our upward, which is 43. And then what we do is we take that number, that's the determinant right there of this 3 by 3 matrix. We're going to multiply by 1/2, plus or minus, just because if our answer was negative, we would change it to be a positive answer. Okay, and after you do all the work, type it in your calculator. 1/2 times that is equal to 757.5. Now, since our grid was in miles, the question said, this is miles squared. So this is our area of that triangle if we look back. Alright. So you can use determinants to find the area of a triangle. Know how to do this. Next, try this problem right here by yourselves. Pause the video and finish. The answer to this problem is 34. Next on the list, instead of using determinants to find area of triangles, let's use it to actually solve a system of two equations. So, what you need to learn is Kramer's rule. Put this in your notes. Kramer's rule. Here is your, you should recognize this, here's your system of equations. ax plus by equals e, cx plus dy equals f. Make sure your system is in this order before you start doing Kramer's rule. Alright, so this guy, Kramer, Gabriel Kramer, born in the 1700s, somehow found this way to solve systems of equations, which is actually pretty cool if you think about it. What he found was, if you, this is divide sign, a little fraction, if you find the determinant, that's what these two lines denote, of a, b, c, d, if you find that number, and on top he found that if you find the determinant of EB, so E, B, F, D, and you divide these two determinants, these two numbers that these will produce, you will get the answer for x. So instead of using elimination, we could use this rule and quickly get it. We'll do an example in a moment. Now let's figure out the y value. The y value of this system of equations, the solution, so I should maybe say this is the solution down here, the x solution, the y solution. The y is half the same. The bottom is the determinant of a, b, c, and d. Now look at a, b, and c, and d. 1, 2, 3, 4. Those are the, you should know, the coefficients. A, b, c, d are the coefficients of x and y on both x and y. So that's a common pattern. Now x, let's go back to x. Where did they get this from? Well, look at the pattern. Okay, E to B and then F to D. So these four numbers right here goes in here. Now over here, we're going to take the determinant of four other numbers. And those other ones are A, E, C, and F. And that's a little pattern too, if you notice. A over here, and then E over here, and then C, and then F. If you memorize this little rule, actually it takes less time to do systems of equations. So, I want you guys to get good at this. So let's do an example. Here we go. Take this system over here. It's already set up. Ax plus by equals E. Cx plus dy equals F. Let's go find the x answer. Alright? I know the bottom is the determinant of the coefficients, which are 9, 3, 4, and -5. Okay, on top, you have to remember that little pattern. E, B, F, D. So, determinant of -6 first. 4. F is -21. Whoa. Got it. So erase that quick. -21 and -5. Okay. If I find those two answers, put this down here, I'm going to get the x coordinate. So quickly, let's do that. You know how to find the 2 by 2 determinant. So multiply these two and get 30 minus, that's the downward, minus the upward, which is -84. Divided by, what about the bottom? Downward, which is -45, minus the upward, which is 12. So x will equal 30 plus 84, 114, divided by negative, what is that, 57. Okay, put that in your calculator, get a nice answer. Okay, which is -2. The x coordinate is -2. Nice and clean. Alright, the y coordinate. The y, I know the bottom is the same. So I'll just 9, 4, 3, -5. Same thing as the x. That's nice. Which means I already know what the bottom is going to be. Y is going to equal, on the bottom we got what? -57 from the last one, from x. Okay, so on top, let's find, let's remember the pattern. A, E, C, F. So A, E, C, here we go, F. Alright, so downward, what is that, -189, minus upward, -18. Which actually, if you do the work, the top divided by the bottom, you get y is equal to 3. And therefore you have your x comma y, and -2 comma 3 is your final answer. Okay. Now at first that might seem like more work, but actually if you do this several times, you get the hang of it, it's actually a little bit less work. So there's how you solve a system using Cramer's rule. And that will be basically the end of this section. I'm going to skip the word problem here. There is a Cramer's rule for a 3x3 system, but it is pretty complicated, so I'm going to save you on that, and you can actually solve a system of 3 equations in your calculator. Just ask me and I'll show you. Let's do one practice example for solving a system using Cramer's rule. Take a moment to solve this practice example using Cramer's rule to solve the system. Pause the video and then you'll see your answer. The answer to this is -1, 3. Alright, this concludes lesson 7